Today we're going to talk about a material that's so common we don't even see it anymore. But it's so critical that if it failed, it could literally trigger a global meltdown. We are talking about rubber and its very, very strange, paradoxical nature.
So, let's start with a little experiment. I mean, think about most materials, right? Like a plastic ruler or something. If you heat it up, it gets softer, weaker, it expands. But what about a stretched rubber band? You'd think it would get even looser, maybe even snap. But watch this. It actually gets shorter. It contracts and pulls stronger. What on earth is going on?
And that right there is the paradox. While pretty much everything else expands and weakens when you add heat, because its molecules are moving further apart, rubber does the complete opposite. And this totally bizarre behavior is the key to its incredible properties. It all comes down to what's happening at the molecular level. To really get this, we need to dive into rubber's strange secret, its unique molecular structure.
Okay, so rubber is what we call a polymer. And you can just think of it as this incredibly long chain-like molecule. It's built from thousands and thousands of smaller identical units called monomers, all linked together. What's amazing is that nature makes these chains with a precision we still can't really replicate perfectly.
Now, in its natural state, these long polymer chains aren't just sitting there straight. The best way to picture it is a chaotic, jumbled-up pile of cooked spaghetti. The chains are constantly being bumped around by heat energy, which keeps them all tangled and coiled up. That messy, disordered state, that's their happy place.
So when you stretch a rubber band, you're literally fighting against that natural chaos. You're forcing those jumbled spaghetti strands to line up in this orderly and, frankly, highly improbable state. The second you let go, the constant vibration from heat energy just kicks them right back into their favorite messy, tangled mess. And that snapback, well, that's what we call elasticity. And when you heat it up, you're just adding more energy, which makes that snapback even more aggressive, even stronger.
But, this amazing natural polymer, it had a fatal flaw. For thousands of years, it was really just a curiosity, not this cornerstone of civilization. And that brings us to the story of how we turned it from useless goo to Goodyear.
Back in the 1830s, there was this huge rubber craze in the US. People were making waterproof boots, coats. They thought they'd found a miracle. There was just one tiny problem: summer. When the heat came, all that rubber melted into a stinking, sticky goo. Then in the winter, it would get as brittle as glass. The entire industry was about to completely collapse.
So enter Charles Goodyear. He was a bankrupt inventor who became obsessed with fixing rubber. He failed for years, landed in debtor's prison over and over, but he kept at it. Then, in 1839, he accidentally dropped a mixture of rubber and sulfur onto a hot stove. But instead of melting, it just charred a bit and became this stable, flexible material. It was a total accident. And this quote really sums him up. Even after a friend told him rubber was dead, that the whole industry was a lost cause, Goodyear was just convinced he was the guy who could save it. And his discovery, born from this sheer obsession and a bit of luck, was about to change everything.
What he discovered is what we now call vulcanization. And here's the magic. When you heat rubber with sulfur, it creates these little chemical bridges, or crosslinks, between those long spaghetti-like polymer chains. It basically ties them all together into one single giant molecular network. Now they can't slide past each other and turn into goo when it's hot, or lock up and become brittle when it's cold.
And the results were just staggering. Look at this. Raw, uncured rubber, it breaks under about 393 kilopascals of pressure. But after you vulcanize it, it can handle over 14.1 megapascals. That is more than 35 times stronger. Goodyear hadn't just made rubber better, he had basically invented a whole new material.
And with that breakthrough, rubber went from being this failed novelty item to the absolute, indispensable foundation of our modern world.
I mean, today, our reliance on natural rubber is pretty much total. It's in the seals and belts that keep our engines from falling apart, the gloves that protect doctors and hospitals, and most critically, it's in the tires that move our entire world. The big tires for trucks and airplanes are still made of almost 100% natural rubber because nothing else we've invented can take that kind of punishment.
And hey, here's a cool little tidbit. Ever wonder why tires are always black? It's not a style choice. They mixed in an additive called carbon black, and yeah, it makes them way more durable. But it also has this crucial safety job. It makes the tires conductive. That way, static electricity can safely discharge into the ground instead of building up and, causing a spark when you're at the gas station.
So, okay, we have this perfect, irreplaceable material, but our entire supply chain for it rests on this incredibly fragile foundation.
It's a vulnerability that puts us, and this is not an exaggeration, one fungus away from a total collapse. To really understand this threat, you have to look back at history. In the 1920s, Henry Ford wanted to break a British monopoly on rubber, so he bought this huge piece of land in the Amazon and tried to build this rubber plantation utopia called Fortlandia. It ended up being a complete and utter disaster because it was totally wiped out by a fungus called South American leaf blight.
So why did it fail so badly? Well, in the wild, rubber trees grow really far apart from each other. But Ford planted them all packed together, creating the perfect breeding ground for this fungus. And the result is that even today, that fungus makes it impossible to grow plantation rubber in its native South America. So now, over 90% of the world's entire natural rubber supply comes from just one vulnerable region, Southeast Asia.
Now here is the absolutely terrifying part. All of those millions of trees in Asia, they're essentially clones. They are all descended from a tiny handful of seeds that were smuggled out of Brazil back in the 1870s. We've created a giant global monoculture that has almost no genetic diversity, and that means it has no resistance to the leaf blight if that fungus ever makes its way across the ocean.
And the stakes here, they could not be higher. One expert warns that if the blight reaches Asia, it wouldn't just be an economic problem. No tires for trucks means no food deliveries to cities. No tires for planes means global transport just stops. In their words, it would be a complete global societal meltdown. So you're probably thinking, well, can't we just make synthetic rubber? And we can, and we do, but it's just not a perfect substitute. See, natural rubber has this amazing superpower. When you stretch it, its polymer chains line up and form these tiny, super hard crystals. Those crystals act like built-in reinforcement, stopping microscopic cracks from growing. Synthetic rubber, it just doesn't do that nearly as well, and that's why it fails in high-stress jobs like airplane tires. We have actually faced a massive rubber crisis before. During World War II, Japan cut off 97% of the Allied rubber supply. It forced this gigantic multi-billion-dollar emergency program to invent synthetic rubber from scratch. It was a national security emergency then, and it really hasn't stopped being one.
And so that leaves us with this really unsettling question. Our entire global infrastructure, our supply chains, our whole way of life, it all depends on this one material that was perfected almost 2 centuries ago. So what happens to all of it if that single, incredibly fragile source finally breaks?